And g'day everyone there in the Bellarine region. This is just a recording of a climate update provided at the AWRI Workshop in July. I'm Graeme Anderson, work with Agriculture Victoria. We have a number of products and we deliver seasonal variability and climate risk sessions right across the state. Now, one of the things we'll talk about is just looking at the last two vintages. Here's the rainfall for 2016 for the whole 12 months, and you can see that there's quite a lot of Australia that was sort of in the decile 10 or decile 8 and 9, and we were sort of average down in this part of the world, but average or wetter over the most of the state. And we'll talk about where all of that moisture came from. The previous year, though, 2015, we had an El Nino in the Pacific, and it does make parts of the country dry. And you can see down in this part of the world was decile 1, which is equivalent of the driest 10% of long-term record, or decile 2 to 3. So we'll talk about those two springs because they're quite different vintages. And one useful app to look at, it's Climate, and it's australianclimate.net.au. You can download lots of nearest rainfall stations, the records there, and just check how's the season going to date. Well, here it is for Port Arlington, and you can see this blue line is the long-term record. You can see all of these are other years. This is just starting at January all the way through. You can see there we were being pretty wetter than average at Port Arlington for the last couple of months, and just that dry month is bringing us back a bit closer. But yeah, pretty wet start to the year this year. We're going to look at long-term rainfall record now. This is Victoria's rainfall from all the weather stations in Victoria back to 1900, and you can see rainfall goes up and down, a lot of variability. Average doesn't happen that often, but you'll also notice in the last 20 years we've had about 4 years above the long-term average and 16 below. So we'll talk about what's going on, what's behind these sort of wetter years and wetter years like last year, and also is there anything going on with this sort of dry pattern. So looking at local rainfall record, here's a long-term record from Port Arlington, goes all the way back to 1885 right through to last year. And you can see you've got millimetres up the side here. This is years where Port Arlington's barely made 400 mils and other years where it's got up to 900 mils. So a lot of variability in the record. We'll talk about where that variability comes from. You can also see that probably wetter phase there during the 50s and 60s, and certainly the last 20 years 14 drier and only 6 wetter, so a few more dry years thrown in there. Port Arlington summer, autumn, winter and spring rainfall, again a lot of variability there. Again, probably nowadays tend to have more often of getting drier autumns than the wetter ones, so this year's obviously going to be down wetter. Winter there is not too bad. It's probably better than a lot of places in Victoria. I think it's probably a bit of proximity to the coast and a bit of variability there. You can see last year's spring just on average, but the one before quite dry. Looking at Anarchy now, Anarchy long-term record 620 mil, the long-term average back to 1889. A lot of variability there. It really stands out. You can sort of see the World War II drought but that last you can see those sort of wetter decades, but then the last 20 years there 14 drier and only 6 wetter, so that bit of a drier patterns in there. When we look at the seasons at Anarchy, plenty of variability. Autumn's probably we still get the occasional wet autumn, but tends to be a bit drier than long-term average. Winter there, not as bad as some places, and again you can see that sort of difference there between the last two springs. So what's behind the wetter and dry years down in our part of the world? You can see here we happen to live at the place, the crossroads of 4 big climate drivers, and to make rainfall basically we need 2 things. First of all, we've got to have a really good source of moisture, and we get most of our moisture from the warm tropical oceans to our north, and when that moist air hits actually the cold air, and you can see all of the cold air whizzes around the southern ocean, and we've got all of these cold fronts that queue up and then sweep across southern Australia. When that's a combination of the moisture hitting that reliable sort of source of rainfall triggers that gives us our reliable rainfall. And we've got the El Nino Southern Oscillation. It's a good source of moisture. The trade winds blow towards Australia. It's normally bringing moisture. In El Nino years, that breaks down and the actual trade winds go backwards, or the moisture's all falling out in the Central Pacific and not over here. So that's some years that sort of moisture supply can be disappearing. And out here, the Indian Ocean Dipole, it was actually a really good source of moisture last year in 2016. Lots of extra moisture up here feeding into northwest cloud bands, and that fed in. And when it hits that colder air down south, then it tends to be average or wetter years. You can see all of these cold fronts off the head around the Southern Ocean. One really important triggers. One thing some farmers note that 30 years ago, if they saw a cold front off the coast of Perth, they'd expect rain 3 days later. And these days, if you see a cold front there, we tend to more often watch it slip to the south. So we'll talk a little bit about what's going on there. One of the things with seasonal forecasting and the difference between wetter and dry years, this is looking at a sea surface temperature anomaly map. So the temperatures along the equator here are always a lot warmer, so that's warm water to swim in, and then it's always cooler down here. But this is an anomaly map, which means it's comparing the temperatures compared to long-term average. So we're going back to a dry pattern here, September 2006. You can see a lot of really extra warm water over here. This sort of colour is where the water might be 1 to 2 degrees warmer than long-term average, and the blue is where water's 1 to 2 degrees cooler than long-term average. So here's a dry pattern because we've got an El Nino happening out here, and we've got this sort of cooler than average water happening to north of Australia. Now all of the extra cloud and moisture, flooding rains and everything would be happening over here, this side of the Pacific when that's going on, and all of the cloud over the warmest part of the ocean there. And when this is happening, then there's a lot less moisture to go to feed into our weather making. So that's a typical dry pattern. Look at the sea surface temperature map here when we say go to a wetter season like the spring of 2010. Okay, here we got October 2010. It's a wetter pattern. We've got a La Nina in the Pacific and cooler water there, and all of this extra warm water. Actually some record warm water that popped up that year, generating heaps of cloud over this part of the world and heaps of moisture that fed into our rainfall patterns that year. So so that's really what a lot of seasonal forecasting is about, just trying to work out where's all of that warmest water and all of that extra cloud and moisture. Is it right in our part of the world, or is it somewhere else? And looking at that pattern there, 2010, you can see that was where that warmer water was, but you can see here this is where the cloud anomaly is. So this colour here is where there's been extra cloud, and you can see that with all that warmer water there's been a lot of extra cloud, and that feeds into our weather patterns and increases the chance of a wetter year when that's happening. And when we look at those dry years like the September 2006, the cooler water is in our part of the world to the north. You can see here this is where there's a lot less cloud around, and again when there's less cloud and moisture coming from up there, there's less moisture to feed into our weather patterns. So when we go through the local rainfall records, if you put them all from the driest years in a row up to the wettest, you get these terciles, the driest third of years, the wettest third, and that in between. So we're going to just look at the local rainfall record and see if this is the standard pattern, and see if there's any different in this pattern when we look at El Nino or Indian Ocean Dipole years' effect on that local seasonal rainfall. So when we look at when there's El Nino years and there's less moisture in Eastern Australia, and we go back and have a look at the El Nino years at Port Arlington, rather than a third of those years being decile 1 to 3, it's more like 2 out of 3 a decile 1 to 3. So you can see it's got quite an influence here, and this is for August, November, that sort of spring weather. The odd one's still wet, but really increases the chance of drier. When La Nina's firing up and there's extra moisture in a lot of Eastern Australia, you can see at Port Arlington doubles the chance of a decile 8 to 10 year wet year. So that's a lot about seasonal forecasting. It really increases the chances, but it doesn't guarantee a wet year, because you can still see the odd one was dry, but it certainly does, all that extra moisture does help. Indian Ocean Dipole effect at Port Arlington, you can see there, really again when it's in its dry phase, really increases chance of drier, and when it's turned the taps on like last year, a lot more chance of getting either wetter or average. So that's what happened there last year. And looking at Anarchy, you can see the El Nino fingerprints at Anarchy, increased chances of dry whenever there's been El Nino, or IOD positive in its dry phase, and La Nina, wet phase, quite strong at Anarchy, and the IOD really reducing the chance of that dry years when it's like last year. And here's the sea surface temperature pattern for where we are in July this year. And so it's interesting that there's been some early discussions about whether an El Nino would develop out here, but it hasn't yet. And basically, right along the whole equator, it's all warm. So there's no really strong El Nino or driver there happening at the minute. But you'd largely say that there is plenty of ocean there that still a good moisture source for potential rainfall this year. This one, there's been a little bit of a watch on to see. We don't want to see too much cooler water up there, and that's what a lot of the forecasters are watching so that this area doesn't go blue over the spring. One of the things also that's been happening of recent, this is pressure pattern, and these colour here are lower areas of lower pressure, and the red is sort of areas of higher pressure. This is just through May and June. And one thing we have had, while there's no strong El Nino underway, we have had more than our fair share of pressure, and that's been hanging around a bit this year. So a lot of the forecasting is trying to look at, well, will that continue or not? Now there's a range of seasonal forecast models throughout the globe really. We've got the Bureau of Meteorology does 1 to 3 to 6 month forecasts. We've got the European model. There's the AWRI model in the US. We've got the UK model as well, and there's a Japanese, Chinese, Koreans. There's a whole lot of global forecast models where they're trying to look at, well, where is the oceans going to be delivering most of the moisture in the coming months. So Dale Gray with Agriculture Victoria puts these together. Here's a number of different models. This is in a newsletter that you can subscribe to. It's free. Just drop an email to the.break@ecodev.vic.gov.au. Dale goes through each month, looks at all of those different climate models, the European model, the Bureau's model, the Japanese, NSAP, NASA, Japan. These are the model runs for July, for August, September, October, what they think will be happening in the Pacific Ocean, the Indian Ocean dipole, and then whether they think Victoria might be drier or wetter. So you can see just if this current outlook as of July, there's 1, 2, 3, 4, 5, 6, 7 of those models have got a thinking Victoria might be a bit drier. So usually in experience, when more than half of these models are starting to say that they think your part of the world is going to be drier, it's worth taking note of. And also the models have a 4 to 6 month outlook, so Dale puts that together as well, and this is for November, December, January. Interesting there, we can see there's a couple with a bit of drier hint, but there's also what's popping into the forecast, those longer forecasts, is a few thinking slightly wetter, especially in parts of eastern Victoria. So 4 to 6 months is a fair way out, but you'd be watching that over the coming months and to see if that wetter signal stays there. So that's what the seasonal forecast update in the fast break. There's basically up-to-date commentary on that and how things are shaping up for Victoria. Right, so what I've talked about is the key drivers behind our seasonal variability. Now, is there anything different going on? So here we've got maximum temperatures records for Victoria going back to 1910, and you can see summer, autumn, winter and spring. While there's a lot of variability in that record, you can see that for all of those seasons, the last 10-20 years, we've been consistently a lot warmer. And I guess with climate change, the Bureau explain it that we're basically squeezing in an extra month of summer. So most of those seasons are all warmer, winter's milder, but of interest is spring's our fastest warming season. You can see the last 10 years there, we've had a number of springs that have been between 1 to even 3 degrees warmer than long-term average. And what's interesting here is that last year, 2016, we had a year that was pretty close to average. And then 2015, that spring was almost 2 to 3 degrees warmer than long-term average. So a really big difference in temperatures between those two. And what we've got here, this is just that spring temperatures for last year, 2016. We're pretty close to average. Because we had a wetter year, there was a lot of extra cloud, and that tended to just keep averages, the temperatures pretty close to average there. When we look at the spring of 2015, you can see it was quite warm over a lot of Australia, and for down in these southern parts, we were, up into the highest, warmest spring on record. So two very different springs, which left their mark on the grapevines. And you can see that pattern there. That's the previous year, 2014. So these sort of colours here are decile 10 temperatures, or hottest 10% of years, or on record. So very warm 2013, 2012, 2011 too. So that's part of a broader pattern of those warmer springs happening more often. Now, one of the things, just reading this paper recently, which was just talking about looking at the relationship between viticultural climate indices and grape maturity, and it just looked at a number of vineyards in Victoria and across Australia, and saying that daily heat summations for the months of September, October and November showed the best correlation to the day of year of maturity, suggesting that springtime temperatures were important relative to the timing of grape maturity. So I guess when you look at those last 2 years of 2015 being really warm, it sort of fired things up early, so you had earlier harvest, and then last year was closer to average in terms of spring, which reflected in the vintage harvest dates. Something that's also a little bit different compared to normal, here's pressure over southern Australia since 1950, where it's been getting a bit stronger. So you can see this region of southern Australia. This is a pressure pattern. Some years the pressure stronger, and they're typically El Nino years, but you can also see there that variability has a trend line about it. So every now and then we pump into higher pressure. So that's something that I expect as the world gets warmer. The pressure pattern over southern Australia was expected to get stronger, and that's what's happened. It's actually being measured. And one of the things just to note, this is that pressure again, and just looking at the June we just had this year, we actually broke a record there for pressure. And that's June rainfall for 2017, and you can see some southern areas of Australia that had either decile 1 or lowest on record. So that sort of, when the pressure's higher, it tends to be not very helpful for rainfall, squeezes more weather to our south. Also, what happens when we get high pressure? Well, we can get warmer daytime temperatures, and so the vine's wanting to fire up earlier. When we get high pressure, really clear night skies and dry air over us, that can be really conducive to frosts, which we've noticed this year too. But also one of the things, while daytime temperatures have been going up, the incidence of spring frosts, and these sort of blue colours here, is just showing that in some areas there's just as many, or even the risk of August to November frosts is just as bad as it was, or in some areas it's getting a bit worse, and that's just because of that rising pressure pattern. So not so bad down south, but it is one of those issues, I guess, that if the pressure pattern continues to rise, then that risk of late frost still hangs around. The last bit just on climate change projections, looking into the future. This is where, with a lot of the climate models, when they put them all together and say, well, if the world's a bit warmer, where might it rain more or less? And so these colours here are showing where in a warmer world the model's expecting it might get a bit wetter. This is where they're a bit mixed, and these areas are where the models think it'll be more likely to be drier. So you can see along southern Australia quite different to perhaps northern Australia. Largely that in a warmer world the tropics expands from the equator, pushes everything south, so that just sort of means that southern Australia is likely to be a bit drier. What's interesting is this is the actual observed rainfall for April to October since '97. So what's been observed has just been those drier bits down south, which happens to include us, and that's what they expected, and that's largely what's been playing out. Still a lot of variability, but mainly to do with that rising pressure pattern. And another good way of looking at it, this is some work done by David Stevens from the Australian Export Grains Innovation Centre, who's looking at rainfall seasonality for the last 100 years and then compared that to the rainfall seasonality since 2000. So obviously we have areas that are summer-dominated rainfall zones and strongly winter-dominated rainfall zones, but that was up to 2000, and then he just looked at what's happened in the last 16 years, and what it found was that most of those zones had shifted south. So and it's a pretty good way of looking at it in terms of future climates, that basically most of our climate zones get shifted south. Now there's successful farming and agriculture happening over all sorts of climate zones, so it's not climate zone that determines your lot, but the adjusting as the zone changes, that does mean that we've often got to adjust our practices or and varieties or whatever as we deal with changing seasons. So there's lots being done to tackle variability in climate change on farms, lots of great stuff, and there's lots of things in our favour with modern day technologies and R&D genetics and innovations which all serve us well. Also improve on-farm and all regional infrastructure is really important, and particularly for a lot of farms down south that we've water storage and water security is a really key one, because we've probably just got to be planning for every now and then the odd dry year or years where there's a bit less runoff. So looking at what our plan A, B and C is there. Lots of things in favour with growth in local and export markets. Also some biosecurity issues, we've got to stay on top of that, really important. Having business management for variable years and incomes always been a really key important thing, and it'll only get more important. Having good farm plans, looking after soils, and basically looking after our natural assets when they're going through either the big droughts or the big wet periods. That's always been important and will be. And also just looking at our soils and how can we improve the health of our soils, so that perhaps if we're making sure that if we're getting the occasional bigger rainfall event, that our soils are set up to soak up more water and store it there for our plants so they can access it when they need to. So soil health is a really important adaptation measure. And one of the key things, of course, which is what the workshops are all about, making sure that you've got really good networks and knowledge channels, so that as we go through each season, we can all share what's worked, what hasn't, and then just plan that into the next season. So hope that's been of use. If you like to get those seasonal updates, monthly updates, just drop an email to the break at ecodev.vic.gov.au, and all the best.